Welcome back everyone, Patrick here, moving on to the next video, still dealing with factoring. So what we're going to be doing is factoring these expressions over here. So for all of these, we're actually going to still be using the method of decomposition. And so far in this section, mostly we've been factoring quadratics with decomposition, but that method could actually be applied to lots of other different expressions. So notice that all of these here, except for the last two, the rest, they're not quadratic functions, but we're still going to be applying decomposition to them. So the method can be applied to other expressions as well. So these are sort of special cases that you may run into, and just in case your teacher does put them on a test or you get them on your homework, I didn't want you being totally thrown off guard. Same process is going to apply for all of these. So let's go through them one by one. So the first one, we got x to the 4 plus 13x squared plus 42. Now this is a common case here of where sometimes the exponents, here you'll have a certain exponent and then the middle will be half of this, right? Because a quadratic, notice that the exponent here is 2 and here the exponent is 1, right? Well, over here the exponent is 4, here the exponent is 2. Notice also we got another one here where we got 8 and 4. So sometimes you'll see that kind of pattern, and a lot of times when you see something like that, it can be factored like a quadratic because that pattern of exponents is still there. So first thing you always check with factoring, can you take out a greatest common factor? And notice that for this particular one, can't take anything out initially. And so let's try to factor it by decomposition. So notice that same process, the a value is 1, the b value is 13, then the c value is 42. And then what we do is we find the AC value, 42 times 1, which is 42. So we find two numbers that multiply to that AC value and add up to that B value, of 13. And what are the two numbers going to be? 7 and 6, right? 7 times 6 is 42, 7 plus 6 is 13. So then what you do is you decompose that middle term into those two numbers as we've done before. So you'd have plus 7, now this is x squared now, not just an x, so you'd have a 7x squared plus 6x squared plus 42, like that. And then from here, same thing, now you factor by grouping. So we could take out an x to the 2 from both of these, right? Instead of just an x like usual with quadratics, we can now take out an x to the 2, and we'd be left with x to the 2 plus 7, right? If we divide both of these by x to the 2, then from these two we could take out a 6, we'd be left with x to the 2 plus 7 as well. And then notice, as expected, that bracket is the same. And so it ends up factoring, this first expression ends up factoring into these two. You also want to check if these can potentially factor further, but notice that they can't. Another thing I wanted to mention is because the a value was 1, when we actually got these two numbers, we could have used the shortcut of where we get to right here. But again, as I mentioned in a bunch of videos, this a value is not always going to be 1. So I recommend going through this entire process of factoring by grouping and then getting the final answer like that, right? And then with these, you can also check your final answer. You can expand this, make sure you get that original expression. Another method that sometimes is used for something like this is substitution. So we could put in maybe like another, let me actually first write the answer over here. So what substitution means is that we're subbing in another variable. So maybe we can sub in like a m for x squared. And so then what we could do is we could take this x to the 4, we could rewrite as x squared squared. Let me just rewrite this over here. Actually, you know what? I'm just going to erase all this. And then what we do is we plug in this m for any x squared that we see. So we'd end up with m squared plus 13m plus 42. And so we end up with a quadratic like that Then when you factor that, you'd end up with m plus 7, m plus 6. And then at the end, you got to bring back that x variable because the original question is in terms of x. So then when you bring it back, x squared, you'd end up with those two factors as well. So that's another method that can be used in this kind of scenario, but it's not always going to work. Like for example, in parts B and C, we got other variables. We have x and y. It's a multivariable expression. So that's not always going to work out. But for something like part D, we can use that method. It's just in this case, we would plug in m equals x to the 4. So we'd end up with m squared plus 5m minus 4, factor that, and then bring back that x to the 4. All right, but we will get to that question once it comes around. So let's move on to part B. We got x to the 4 plus 2x squared y minus 24 y squared right here. So notice lots of variables here. We got x and y. First thing we always check for, can we take out a greatest common factor? Notice that in terms of the numbers, we got a 1, 2, negative 24. Can't take anything out in terms of the numbers and the variables. There's x's here, but there's no x here. There's a y here, but then there's no y over here. All right, so we can't take out any common variables either. So let's do decomposition. So we got an a value of 1, we got a b value of 2, and then we got a c value of negative 24 over here. And then we get an AC value, which would be negative 24 times 1, which is negative 24. So we find two numbers that multiply to negative 24 and add up to 2. So what would those two numbers be? It would be 6 and negative 4. Right? 6 times negative 4 is negative 24. 6 plus negative 4 is positive 2. So then what we do is we decompose this middle term. Just be careful with keeping the variables the same. Okay, you could switch these as well if you don't want to deal with the negatives here. I'll just keep it like this, and then from these two we'll factor out a negative value. But just be careful with the variables here. So here, x to the 4, x to the 2, so there's an x that's common with these two, so we could take out an x to the 2. Notice a y is not common, there's no number that's common. So if we take out x to the 2 from this, x to the 4 divided by x to the 2 would give us just x to the 2, plus 6x squared y. We took out an x to the 2, so that cancels out, so we're just left with a 6y, like that. Okay, so just be really careful with the algebra here. That's why that previous section of where we were dealing with greatest common factors is super important for these kinds of questions. Those fundamentals are important. Now let's move on here. Now because this is a negative, we know we're going to take out a negative for sure. Notice we got a 4 and a 24, so we could definitely take out a 4. We got x to the 2 here, but there's no x over here, so we can't take out an x from both of these. But notice we have a y to the 1 and a y to the 2, so we could definitely take out a y to the 1, or just a y. Let's not even put the exponent. Okay, so what I recommend doing, these are a little bit more complex, so let's also do them on the side. So what we're doing is we're taking out a negative 4y from this expression. The negative 4's cancel, the y's cancel, so we're just left with x squared over here. And then we got negative 24y squared. We're taking out a negative 4y as well. Negative 24 divided by negative 4 is positive 6. Y to the 2 over y to the 1 gives us just y. So we'd end up with positive 6y like that. And as expected, the brackets are the same, right? So we can now take out that same bracket, and we'd be left with an x squared minus 4y, like that, right? So that ends up being the answer for part B. And as usual, if you want to go ahead and expand it, so we got x to the 2 times x to the 2 is x to the 4. X to the 2 minus 4y gives us minus 4x squared y plus 6x squared y minus 24y squared. Those are like terms because the variables, the combination of variables and exponents is the same, x to the 2y, x to the 2y. So negative 4 plus 6 does indeed give us that positive 2, and then those two n values are the same as the original. Right, so especially for these more complex ones, if you do have the time on a test, make sure that you're expanding to check your work. Now moving on to part C, so we got x to the 4 plus 10x squared y squared plus 21y to the 4. So notice this is another type of multivariable expression. So same thing, can we take anything out initially? Notice that x variable but no x variable here, y variable but no y variable there. And then this is just a 1, so we can't take out any numbers. So let's go into the decomposition. So we got a equals 1, b equals 10, c equals 21. 21 times 1, right, the AC value would give us 21. So two numbers that multiply to 21 and then add up to that b value of 10. Those would be 7 and 3. Like that. So then what we do is we decompose that middle term. Be careful with the variables here. Into those two. And then we got the plus 21y to the 4 at the end. So from here, notice that from these two, now we're going to factor by grouping. From these two, we could take out an x squared, and we'd be left with x squared plus the x squared comes out, so we're just left with 7y squared. And over here, 3 and 21, we could definitely take out a 3. X to the 2, there's no x here, so we can't take out anything in terms of x. Y to the 2, y to the 4, we could definitely take out a y to the 2. So from 3x squared, y squared, we're taking out a 3y squared. So we're taking out the 3, we're taking out the y squared, we're left with x squared. And then let's do this down here. That would be what, 7y to the 2, like that. As expected, those two brackets should be the same. Right? If those two brackets are not the same, then you got to go back. Something is off. So that would factor. We could take out that factor, and then we're left with x squared plus 3y squared, like that. And again, if you want to take this, check your answer, expand it. You can do that as well, just to be sure that you're getting the right answer. But I'm not going to do that for this one. You can do it if you like, just to practice your algebra. Now moving on to part D, notice this is another combination of where we just have one variable to work with, which is nice. And notice it's that combination of where we have like an 8 and a 4, so we have this leading exponent is double this one in the middle. So it follows that same pattern of exponents as a quadratic, if you will. So let's actually, for this one, do that method of where we sub in a variable. So what I'm going to do, I'm going to let m equal x to the 4. So this x to the 8 we can actually rewrite as x to the 4 squared plus, this would be 5x to the 4 minus 14. And then let's bring in that m for the x to the 4. So we'll have m squared plus 5m minus 14, like that. So now we could just factor this like a regular quadratic. Notice the a value is 1, b value is 5, c value is negative 14, ac is negative 14. The two numbers that multiply to negative 14 and add up to that b value of 5 would be 7 and negative 2. Like that. 7 times negative 2 is negative 14. 7 plus negative 2 is positive 5. I'm going to put the negative in front this time. You don't have to, but just so we could factor out a positive from here. So from these two, we could take out an m. From these two, we could take out a 7. Then we could take out that bracket, and we'd be left with m minus 2, m plus 7. Right? M plus 7 is what's remaining. But this is not in terms of m, it's in terms of x, right? So now we got to bring back that x to the 4 over here. And we end up with those two factors right there. And then you want to check, do these two factors factor? and they don't. So that ends up being the final answer right there. So that's another way. You didn't have to do the substitution like part A. You could just decompose this to plus 2x to the 4 or minus 2x to the 4 plus 7x to the 4, and then factor by grouping, and you'd get to this over here directly. So either or works for part D, just as long as you're getting that same solution right there. Now moving on, these two are fairly similar. We got 4x minus 6 squared minus 8x minus 6 minus 60. So notice that in this case, we have this x minus 6 that is common. Now, one thing we could do, we could expand everything. But that's going to take us quite a while because we got to FOIL these two brackets, then bring that 4 in, then distribute this -8 into this, then collect all the like terms. It's going to take us quite a while. So what we can do is we can do another change of variable here because we have this x minus 6 that's common, and this to the power 2. This is just to the power 1. So what I'm going to do is I'm going to let m equal x minus 6 like that. So we'd end up with 4m squared minus 8m minus 60 like that. Right, 4m squared minus 8m minus 60. And then we could factor this, then we could bring back that x variable. So from here, we could take out a 4 like that. And then let's factor this bracket separately. So same thing, decomposition, a value is 1, b value is -2, c value is -15. AC value is -15. Two numbers that multiply to -15 add up to -2 would be -5 and 3. -5 times 3 is -15. -5 plus 3 gives us -2. So then this decompose like that. From these two, we could take out an m. From these two, we could take out a 3. And then we could take out an m minus 5. Like that. And then we can't leave it like this. We have to bring back this x minus 6 for m. So here's where there's going to be a little bit more algebra still. Let me just write out that line. So now I'm going to bring back the x minus 6 for the m. And then we still have this minus 5. And then I'm going to bring the x minus 6 for this m. Then we got the plus 3. So then notice we can still further simplify these. -6 plus 3 gives us minus 3. Like that. And so that there ends up being the final answer. So if you took something like this, you can actually do this as an experiment. I'm not going to do this in this video just because it would take quite a while. But if you want, what you can do is you can expand everything, simplify all the like terms, and then you'd end up with the quadratic, and then that quadratic would factor into that, right? If we expand this, the quadratic you'd end up getting is that right there. If you take all of this here and you expand it and simplify it, this would be the quadratic you get. And then this quadratic factors into those two right there, into these two factors. All right, but again, I feel like that way is going to be longer. If you do see something like this, like a pattern like this, I'd recommend subbing in variables, dealing with that, and then bringing back that x minus 6 over here to get your final two factors. And then finally, part F. This is a very similar one, but there's actually going to be just a very subtle step at the beginning. We got x minus 4 to the 2 plus 6 bracket 4 minus x minus 40 over here. So notice that very close, we can almost plug in a variable for this x minus 4 and 4 minus x, but they're not the same. But we can make them the same. So the 4 minus x, what we can do, we could take out a negative, factor out a -1 from this. So we'd end up with -4 plus x. Basically, all of the signs change when you take out a -1. Right? If we just redistribute this -1 inside the bracket, we'd end up with this. And then rearrange these. -4 plus x is the same as x minus 4. So this 4 minus x is the same as negative 1 times x minus 4. So what we can do, let's go back to this. So we can rewrite this. Don't forget this 6 here times negative 1 times x minus 4 minus 40. And so what we would end up with, x minus 4 squared. This is negative 6. And then we got the minus 40, like that. And now notice those brackets, they are the same. So what we can do is now, let's plug in that variable. M would be this x minus 4. And now let's rewrite this m squared minus 6m minus 40, like that. And now we could just factor this. Can we take something out initially? No, we can't. So now let's go into the decomposition. A is 1, B is negative 6, C is negative 40, AC is negative 40, 2 numbers that multiply to negative 40, add up to that B value of negative 6. We get what? Negative 4 and 10? Negative 4, no. This should be switched up, sorry. Yes, negative 10 times 4, and then negative 10 plus 4. Right, negative 10 plus 4 is negative 6. Negative 10 times 4 gives us negative 40. So then decompose like that. From these two, we could take out an m. From these two, we could take out a 4. Then we could take out an m minus 10. Left with m plus 4, like that. But then remember, it's not in terms of m, it's in terms of x, so the final answer has to be in terms of x. So we let m equal x minus 4. So what we can do, let's do it over here actually. So we can now put this x minus 4 for the m, and then we could put the x minus 4 for this m over here. Yeah, so we'd end up with x minus 14, and then the 4's negative 4 plus 4, that's just 0, so we're just left with an x here. So we'd end up with x minus 14. So that actually ends up being the final answer right there. A nice simple quadratic. So if you took all of this, if you went the long way, took this, expanded it all, you'd end up with x squared minus 14x, and then factoring this, you could just take out an x. And you'd end up with that answer right there. Okay, so multiple ways to do these kinds of questions. So when you run into scenarios like this, maybe try different methods so you get super comfortable with whatever works for you. But I feel like I went through the quickest methods, if anything, in this video in case you're pressed for time on a test.